Hi all, I wanted to talk a little bit about the Steam Deck today. I know there have been plenty of videos out there on it, but has your Steam Deck been collecting dust? Are there dust bunnies surrounding it because of infrequent use? And what about temperatures? And have we been wasting money on all these crazy cooling gizmos? And also, while docked, what about using proper USB cables? How much speed do you actually need with a docked deck? And how do you tell if you have a good enough cable to do what you want it to do? And also, I have a nice Steam Deck sensor panel design that I designed with AID64 for when it is docked, which is most of the time now for me. So let's look into a few things here, starting out with temperatures. First, let's talk about the Steam Deck temperatures, particularly the original version, as that's what I have. If any of you have used any of these add-on cooling devices, leave a comment on what you think about them. It looks like there are all kinds of cooling fan attachments, Peltier coolers, and more claiming to lower the deck temperatures. Most of these, if not all, seem not to work very well. But no one is asking one important question. Do you need to cool the Steam Deck more than the factory design? It seems that many of us want to apply PC cooling techniques to the Steam Deck. Why? Because we can. But is it necessary? As I looked at the operating temperatures of the deck, I questioned them until I did a little research on the deck. It's true that you need to do what you can to keep temperatures under control with your own PC builds, especially if you overclock, change voltages, and such to squeeze maximum performance out of your hardware. Some processors are designed to be overclocked. In those cases, increased cooling capacity is needed beyond factory-supplied coolers. If you are dealing with a device like the Steam Deck, you probably shouldn't be trying to overclock it, as it really was not designed to do so. The deck is engineered from the factory with a custom cooling solution to run a certain range of temperatures, and it will be fine unless you exceed the manufacturer's recommended environmental conditions. So don't ignore the design of the deck and think that you can do better than engineers at Valve who spent much time and testing on it. Most of us are aware of the deck's specifications. It's designed to run between an ambient room temperature of 0 to 35 degrees centigrade or 32 to 95 degrees Fahrenheit with a processor maximum temperature of 100 degrees centigrade or 212 degrees Fahrenheit with no detrimental effects. And then it will start to throttle back at 5 degrees centigrade or 12 degrees Fahrenheit more over the maximum. As far as modifications to the deck, there is no issue with installing different cases as long as they adhere to the original specification of Valve's deck. I've seen the back case replacements that have extra vents, metal plates, fans, and such, claiming to make it cooler. Valve designed the deck back cover to enable proper airflow where it is needed using negative pressure inside the case. With negative pressure, more air is exhausted than what is taken in. I know this is hard to wrap your head around, but in the deck, a pressure relationship is established because of the tight spaces. The fan intake is restricted to set up a negative pressure that is less than the pressure outside the case. This helps to pull more air in, through, and around the tight spaces to cool it where it is needed before it is exhausted through the fan and the processor heatsink radiator. To maintain operation limits with the deck, it's necessary to keep the intake clean. And Valve has engineered the deck to have the airflow around components in a particular manner, and if the airflow is disrupted, it can overheat in areas that you are not aware of. So installing back covers that have cooling plates restrict the flow across the metal shield, and cases that have vent holes can also disrupt the negative pressure inside. If the heatsink fan speeds run slower with a modification, then other components may not be receiving the airflow that they need. Valve designed the original back case to properly direct airflow in, through, and around all the tight spaces inside the deck. So chime in and comment on your experiences with some of these various cooling remedies and if you ever had caused an issue by implementing them. The air needs to be pulled through the case to create negative pressure inside. With negative pressure, there will be no slow-moving air pockets like in a positive pressure setup. Think of it as creating a vacuum inside, which draws air in more efficiently. So use some common sense, but there may be one gadget that seems to help a little bit. And the cooling fan by JZox. It draws air in and through the deck exhaust vent. Works similar just as the factory fan, except a little more efficient and a little more noisy. I took some temperatures with AID64 while stressing the deck. Think about how many Steam Decks are out there collecting dust. Mine was, as I used it only occasionally. Just look at the number of used ones for sale on eBay. Now my PC has some age to it. I have it installed in a Fractal Core 500 Mini ITX case, and it has an older 8-year-old ASRock A88M ITX board in it with an AMD A10-7890K CPU, or APU shall I say, and Windows 10. So rather than purchasing all new hardware, I figured I might as well put the deck to work as a desktop replacement. I installed Windows 11 on it, and most of the software I use is Windows based. I know that you can do a lot in Linux with Wine, but I've done that in the past many times, but I don't want to jump through all the hoops anymore trying to get everything to work. So Windows seems to run fine, and if I choose, I can sit on a back patio in the summertime to play a few games with it if I wish. So let me show you what I've done before we look at these temperatures. And then I want to talk shortly about USB cables. At this point, I don't have all my Windows software installed yet, but I do have a few Steam games installed just to test things out for now. But here's a photo of my desk area using the Steam Deck as a second monitor, and the display on that monitor is showing the AID64 sensor panel that I made. On my PC, I had a 7-inch second monitor, and I was displaying the sensor panel there on that. But the dock that I'm using is a Garrett keyboard hub. Now, I talked about that in a previous video. I purchased it on Amazon, which they're showing out of stock now, but I see you can order it still on AliExpress. Now, it's only a USB 3.0 dock, but that's fast enough for me. But it's tucked in and back behind my main keyboard on the keyboard tray. You can see it there, along with the little amplifier for the audio, which is fed from my Samsung monitor. So since there are only 3 USB 3.0 ports available on it, I use one for my old SATA 2-drive USB 3.0 dock. And the second port, I have an old USB 2.0 4-port connector that has my wireless mouse and my main keyboard plugged into it. Then the third port, I have a 4-port USB 3.0 hub, which is sitting on the right in the photo. So I can plug in any memory sticks, CD drives, or anything such as that. So I really don't need anything external faster than USB 3.0 5 gigabyte a second speeds right now. So looking at the temperatures, here in my basement, it ranges from 14 degrees centigrade or 50 degrees Fahrenheit in winter to 20 degrees centigrade to 69 degrees in summer Fahrenheit. So right now the ambient temperature here is 17 degrees centigrade or 63 degrees Fahrenheit. Now Valve says the deck can handle up to 35 centigrade or 95 Fahrenheit ambient temperatures, though at the high end I'm sure it would start to throttle back if it was stressed. So here are some temperatures, and this first one is the temperature at idle with the JZOX fan off. You can see everything is running pretty cool, temps are cool, power level is low. Next, we see after 2 minutes of stress, we see we're drawing 15 watts power, a little over 15. And the temperature has risen to 82 degrees centigrade. Now the deck fan speed is switching between 5 and 6,000 RPM. I kind of caught it between on this screenshot, so it looks like it's way up there more than it is. But that's with the JZOX fan off. To get a good idea of what full stress will do at the ambient temperature that I'm in. So you can imagine what it might be if we're in a really hot ambient temperature running full power like that. So next, I turned on the JZOX fan on high, and you can see the temperature dropped down to 75 degrees centigrade. And the deck fan is running about 5,900 RPM. So stopping the stress test and letting it cool down a little bit, I turned the JZOX fan on low and ran a stress test again for 4 minutes. Looking at the temps, we can see that the temperature is holding at 78 degrees centigrade, and the deck fan is running around 6,000 RPM. And again, we are running at a little over 15 watts power. So last, after cooling down the deck, I started the JZOX fan on high and ran the stress again. So the temperature is 73 degrees centigrade, and the deck fan was running around 5,600 RPM. Now, it'd really be annoying to run this JZOX fan on high for any length of time. So depending on room temperature, if you had a long gaming session, I suppose you could stop for a while and turn it up to let it cool down a little bit. But you would probably need to find a sweet spot, depending on what game you might be playing and keeping that JZOX fan so it wouldn't be so annoying. What about USB cables? Now, I have this nice little USB cable tester here, and it will accommodate different connectors on USB cables, and it will show you if you actually have a bad cable by the wiring, if the wiring is actually working properly, if you have it open in the wiring. Now this first one you can see is a standard USB 2.0 cable, and the only data lines are connected are data 1 and data 2, so you're going to get 2.0 speeds through this cable. And incidentally, if we're concerned about a power charging on the cable, it will shows you also if the power lines are active. And on this second photo here, we can see this cable is a high-speed cable, because not only does it have the data lines connected, it also has two sets of transmit and receive lines that are also active, enabling super speed over USB 3.0 and above. Now again, US 3.0 is standard is 5 gigabytes a second. That's fast enough for what I need and all my equipment that I plug into it. So that'll do me fine, but there may be situations where you want faster transfer speeds, especially if you're using a USB drive to do a lot of work or operating system loading off of it, then you're going to need that faster speed. So that's about it for today. You have any comments, any ideas, or any experience with anything I talked about that you may had some headaches, let everybody else know. Knowledge is power. So have a good day, and God bless.